here's the amplifier board. 4 screws just holding that top cover on. Washers on the bottom. I always forget which way around the washers go, and screw heads. Okay. So yeah, this uses, I think it's an AC 128. I can't remember off the top of my head now. Let me just get the info on it a minute. Okay, I've got the schematic on it. So yeah, it uses an output pair. It's an AC 176 and an AC 128. That's these two. That's the outputs. It's getting a little bit closer. It uses this funny T2 transistor in position T3. Now on the circuit diagram that's shown as OC71. Now I think the older boards were OC71, which is like a glass. The OC71 here. Oops. Yeah, so that's an OC71 there. It's like an old glass transistor. In fact, you can see the black coating has rubbed off of that one. So let's put a dab of black paint back on that, because they do get affected by light, so that's why they've coated them black. But yeah, that's an OC71, so that would have been in this circuit on older versions. This is a later version. So that's the driver transistor, that's the outputs. And we've got pre-drivers and other bits and pieces in here. We've got the lock-fit BC148, should be okay. It did sound really nice, so I can't see there being a problem with that. Those, because that would generate a bit of noise on it, but you never know. We'll check it when it's all back together. There's a test link in here that we need to take out to test the quiescent current on it. And I can't remember if I've done a midpoint voltage on one of these before, but I'm sure there's a test point for that. It's usually between the two. It's probably between here, I expect. Between those last two resistors. Feed the output stage. Yeah, so it'll be the midpoint voltage will be in between those two there, I expect. We'll do that later on. These little pots as well, these little trimmer variable resistors, these can get noisy. Again, I had a Hacker Super Sovereign, very similar board layout to this, slightly different configuration, but the problem was, I think it's the same pots, a 10k and a 50k. I think it was the 10k was really noisy. Changing it made it totally silent. Yes, again, these carbon resistors, they can also generate noise. So really, if you've got noise, you're going to end up pretty much repopulating the whole board virtually, apart from the capacitors, and not the electrolytics, but the other capacitors. I've not found any of them to be faulty in one of these boards yet. Got these strange upright resistors here as well, look. Again, I'm not sure if they're carbon or not, but they're very different, aren't they? Let's these ones here, look, just like a square block. I used to think they were capacitors till I looked a bit more carefully, and yeah, they are actually resistors. Their little colour codes are painted as stripes on the top there. It's a little bit different. So what I'm going to do now, I'm going to get these capacitors out of circuit. I mean, if anywhere is going to have dodgy capacitors, it's going to be here. And once we've got them all out, I've replaced them all, then we'll go through and check them all on the ESR meter. Okay, that's the amplifier board now all recapped, or all the electrolytics anyway. Something I've done on this, I mean, you might be able to see there, is I've put little 90-degree bends on the end, because some of the leads are quite long, and sometimes just stretching them across looks a little bit untidy. This is a very visible board, so Again, I've used all the same brand capacitors, and I've made sure that all the values are facing up as well. So yeah, looking good, apart from the fact I've just soldered this one in backwards. So let me get that one back out. That's typical, isn't it? So well worth a scan around just to make sure. But yeah, this one here, I put it in backwards originally just to measure where to bend the leg, and I've gone and soldered it in backwards. So I'm just going to pop that one out and reverse it. Then I'll show you what I'm going to do next. Right, there we are, all done in the right way now. You can tell with these modern capacitors which side is positive, because they've got like a little crimp. You see the crimp on the end of them? That on these modern ones is always the positive. So yeah, you can easily just visually check that you've got them all the right way around, and I have got them all the right way around now. So the next thing to do, you've got a few sort of stress points on these boards. This is one. This is the plug socket. Now, very often you can get a dry joint on these. These are okay, but what I'm going to do is I'm just going to reflow the solder underneath, just to give it some fresh solder, make sure that we don't lose any of those in the future. And the other is the two speaker posts. Again, same thing. Again, they're not loose at the moment, but pulling them in and out does take quite a bit of force, and it's very easy to just crack them off. So I'm just going to reinforce those. Then luckily this board, you can actually get to the test link in there without taking the cover off, and you've got a hole as well for one of the for one of the adjustment points, one of the variable resistors, and the other one's easily to get to. So I can put this back together, because this top piece does form part of the earth. And something as well that can happen, I've not had this yet, but apparently it is starting to get more and more common, is these output transistors, although they haven't got a shield wire in them, they can develop a short between the base collector or emitter and the actual can itself. And because they're actually screwed to a heatsink, and that heatsink is earth, that actually can cause a problem. If they're just floating in air like this one is, then no problem at all, because they're not actually earthed out. Eventually it will short the junctions together, I'm sure, but yeah, something to watch out for. I have got a set that I'm working on at the moment over there, a Dynatron Gypsy, that's got a bad output transistor. It's not common. I've not had to replace hardly any. So well, I'm going to get this put back together. I'm going to reflow those joints and join me again in a minute. Okay, that's the board all cleaned up now. I say I've reflowed all those. Yeah, so just going to screw that back together. Then we'll have a look through the old capacitors. Okay, capacitor time. So here's all the old ones. In total I've changed 14 by the looks of it. So let's start with the mainboard ones first. So first of all we've got 220. Again, I don't expect any of these to be bad, to be honest, but it's always nice to check them. Okay, that one's got a bit high, 255, but nothing out of this world. What have we got here? 6.8. These 6.8 seem to be getting a little bit harder to get hold of. Oh, that one's gone fairly high. That one's gone up to 9. Again, probably wouldn't be a problem. What have we got here at 22? .34, so again gone a bit high. Another 22. Oh, hello, that one's gone up to 64. Yeah, that one's way too high. So that would have been causing a problem in the circuit somewhere along the line. Can't remember where that one came out from now, I'll have to have a look. This one's a 2.2. 2.5, so yeah, no problems. Another 6.8. Again high, reading at 8, but it's below 10, so it wouldn't do any problem. So another 2.2. Reading 2.4, so no problem. Yeah, so I was good on these as well. So, you know, these are probably the old Philips caps. Another 6.8. Reading 8.8. So all the 6.8s are up around 8, but then I expect the new ones ain't far off that either, because they're probably still within tolerance. So only one real bad capacitor there, and that's one of those 22 microfarads. So let's start with the biggie, the 470 off the amplifier board. $4.98, pretty good. No problems with that one. If we got your 150. 190, so that one's gone a little bit high. This one as well is 150, I think. It's very difficult to read it because the printing's not been done very well on it. Right, that one's gone up 50 microfarads, quite high. I did notice that the terminal on that one is quite badly corroded. I don't think it would have been long. Either some electrolytes leaked out of it, or it's got corroded by something, but yeah, it wouldn't be long before that one, I don't think would have lasted much longer. He would have snapped off, I'd have thought. Let's come back out again. What else have we got here? We've got a 47. $52, so again that one's okay. 2.2. Oh, 2.26, look, can't get much closer than that. And what's this one? This one is one I can't really read. I think this was on the circuit diagram of 15 microfarads. 28. Yeah, it might be a 22 actually. It's 26 volts. Yeah, I think it's 22, that one. Again, the label's all to pot on it. Yeah, 22 that is. So again, a little bit high. So really, one of those was no good. A little bit too high. That was that corroded one. So out of 14, only 2 really needed changing. But how long would they go on for before they start packing up? So the whole point of recapping it is to prolong its lifetime. And I mean, as long as you can keep it looking original like that, I mean, that, you know, that's quite a good look. I've kept them all blue. They're all axial still. You know, that'll last, well, another 20 odd years, I'm sure. Right, so time to start putting it back together, I think. We've got some aligning to do. So say with this one I need to do the quiescent current and the midpoint voltage. I'm going to need to remove this link. And we've got some alignment, some RF alignments to do on the actual tuning dial itself. So bear with me, I'm going to get it all back together.